Hey, one of the things that we are going to talk about today is how to find a probability, um, the numbers that go into the fraction pretty quickly. So we know our options are making a tree diagram, making a list, or multiplication. And I've just kind of barely talked about the multiplication, so I'm going to talk about that a little bit more today. So let's say, for example, well, let's do a couple of examples. So here's our first one. Let's say I have a dice. I'm going to roll it 3 times. And I want to know what's the probability of rolling a 2. Well, I know I'm going to make a fraction. And the first roll, there are 6 possible options. The second roll, there are 6 possible options. The third roll, there are 6 possible options. Here, let's do a fourth one just so we don't leave that 3 sixes together. So let's say we're rolling it 4 times, okay? Each time there are 6 possible options of what could be rolled. I want to know what's the probability of rolling just the number 2. Well, there's only one possibility, like one option first time, and it's just the number 2. There's only one option the second time. It's the number 2. Then there's only one option the third time. It's the number 2. And there's only one option the fourth time. It's the number 2. So we multiply each of these together. The top is easy. 1 times 1 times 1 times 1 is just 1. But the next one is a little bit more challenging. So I'm just using a calculator on my phone. And it ends up being 1,296. So that's the probability of rolling a 2 every single time when I roll the dice 4 times. What if I just want an even number every time? Well, I know I still have 6 possibilities every time, but there are 3 even numbers, 2, 4, and 6. So the probability of rolling an even number every time, I can multiply 3 times 3 times 3 times 3, excuse me, is 81. And on the bottom, it's still the same as before. Okay, so this is for the quick way to solve if the events are independent. And I'm going to talk more about what that means in another video. But let's talk about if the events are dependent. So what if I have a hat full of names and I want, or how about letters? We'll go with letters. I have a hat of 10 letters. A, B, C, D, E, F, and there's 10 of them. A, B, C, D, E, F, G, H, I, J. And I say, what's the probability of getting A, B, and C in that order? A first, B first, C first. Well, the first time I draw, there are 10 cards in there. Once I take a card out, I don't put it back in. The next time I draw, there's only 9 cards in there. And if I take it out and I don't put it back in, then the next time I draw, there's only 8 cards left in there. Well, if I do care about the order, the first time there's only 1 card I want, and it's A. And the second time there's only 1 card that I want, and it's B. And the third time there's only 1 card that I want, and it is C. So then I can multiply those together. 1 times 1 times 1. Wow, I was about to write 3. 1 times 1 times 1 is just 1. 10 times 9 times 8. I just used a calculator, and that's 720. Excuse me. This is for if the order does matter. What if the order doesn't matter? What if I say I want A, B, C, but it could be in any order? C, B, A, B, A, C, C, B, C, A, B, whatever. Okay. Well, still the total, the first time there's 10 cards, 9 cards, then 8 cards. But because I'm okay with any of these being first, 3 possibilities the first time I draw. Then, because I'm looking for the probability that this does happen, I only have 2 chances left, or 2 choices that I want, and then there's only 1. So when I multiply these together, I get my 720, and 3 times 2 times 1 is 6. Always simplify as much as you can. So I'm going to simplify. I know they're both even, so I'm going to divide by 2, and 720 divided by 2 is 360. It just so happens these are both divisible by 3, so 3 divided by 3 is 1. 360 divided by 3 is 120.